So in this section we're going to look at some generic functions, generally lines and parabolas, and then we're going to take a look at the square roots of these functions. So in this example I haven't given you the graph of the original function, I've only given you the equation of it. F of x equals 3 minus 2x. It's a line, 2x, no x squared to make it a parabola. It's not written in a really good format in order to graph it. To graph it, it would be better written as f of x equals negative 2x plus 3. And if we think back to Foundations in Pre-Calculus 10, this tells us that the y-intercept of the function is 3. So the function crosses the y-axis at 3. And the slope is negative 2x, meaning for every space we move to the right, the function moves down by 2. So we'd have another point here at 1, 1, another point here, and so on and so on. And we can extend those points to the left as well, keeping that same slope. Try that again. Now ideally that's a straight line, but my drawing skills on my iPad are not that great. What we're looking at now is determining the square root of the graph of this function. So that would be y equals the square root of negative 2x plus 3. To find that, all we need to do is take the square roots of each of the points, the y value specifically, of the existing graph. So if we go from the far left point that I have, we have a point at negative 2, 7. 7 is what matters here. So we take the square root of 7. We'll have to estimate that a little bit. Calculator is a good idea here. Square root of 7 is approximately 2.6. So for the square root of this function, that point that's at negative 2, 7 would actually be negative 2 and 2.6, roughly there. Next point is at negative 1, 5. So we'll take the square root of 5 to find the point on the square root function. Square root of 5 is 2.2, so that would be approximately there. Next point at 0, 3. Again, take the square root of the height, so the square root of the y value. Square root of 3 is approximately 1.7. Next point at 1, 1. Again, the height is 1. Take the square root of that is also 1. So that point actually does not move. Next point at 2, negative 1. We'll take the square root of negative 1, which is actually not possible. So this function actually will stop. We'll actually have one more point that is not actually drawn on the graph, but that point is always going to be the x-intercept of the function. X-intercept always has a height of 0. Square root of 0 is also 0. So the graph of the square root will actually start at that x-axis point, and this function will actually curve up to the left to follow those points. So all we're doing to find the square root of a function is taking the square roots of the y values of each point and drawing a new graph that matches.